Hello, good morning, everybody. It's a real pleasure to be here, to be able to talk about these topics with other people who share this excitement about such topics. So, real pleasure to be here. So, thanks again for Wi-Fi, but also to FGF Rio for hosting us. I'm going to talk about open technologies under geopolitical tensions, a little bit more from the perspective of an open technology, which is RISC-V standard in the semiconductor industry. But quickly, a few words about me. So my name is Krewer. This is a picture of me with more hair. So I'm currently working for the French development agency, AFD, who are sponsoring my PhD at the Center for Economics at Sorbonne Paris North University, where I take an institutionalist lens to commons to open technologies and analyze institutional transformations between closed and shared forms along the global value chain of semiconductors. So I'm not an electronics engineer. It's important to mention before I start talking about RISC-V. I'm looking at this from the perspective of political science, which is also the perspective I had during the past 10 years working in the promotion of open technologies and digital commons. Let's get into our main subject here, which is first a bit technical. I do not expect everyone to know what RISC-V is. So here's like a short, brief explanation. RISC-V is an instruction set architecture. Instruction set architecture is basically the interface between hardware and software. So you have a software with programming languages, with different commands, and in between the software and a chip, so basically the computer, there's ISA, which translates the software into basic instructions, the basic logical functions of a computer, so calculations, memorizations, etc. So it's quite critical because it's at this interface. It has huge network effects. Designing chips is extremely costly, so building based on certain ISAs really defines like a path for the future, but also the whole software ecosystem that rely on ISAs are really long and hard to rebuild. And historically, this landscape has been dominated by proprietary technologies. In general, chip design was rather a business of big firms and secrecy. And like the two dominating ISAs are x86, which is owned by American companies Intel and AMD, and ARM, which was a British company that was bought in 2016 by SoftBank. RISC-V is really creating some change in this landscape. It was developed based on previous attempts to create open royalty-free ISAs at UC Berkeley, so in the US, in California. It's open, royalty-free, so I guess many people here understand this, that it means there's a permissive license that allow any kinds of implementations. And it also has like a specific technical aspect to it. It's a reduced instruction set computer, so it means it's very basic and simple instructions in opposition to complex system, which makes it a very basic ISA that is easy to customize and to build on. And so this has created a lot of interest in this initiative, and now RISC-V is an international alliance where a lot of companies are collaborating around the world, and you can find Google, Huawei, Qualcomm, Nvidia, many of the big companies in the industry from various countries. So of course, this success has led to a lot of political attention. So several countries have started to say we need to support the adoption of this standard to support our domestic industry. So for instance, China has launched a huge industrial strategy to make their companies build on top of RISC-V architectures. The EU has also integrated this as part of its strategic autonomy. The government of Brazil is even a board member of RISC-V International at the moment. But at the same time, it also has raised some questions. So especially in the US, that has historically leveraged standard essential patents, intellectual property rights to protect its domination in the field. For instance, during the trade war with Japan in the 80s, RISC-V is also considered as a potential threat. So in 2023, for instance, several US lawmakers, including Marco Rubio, wrote an official public letter to the Department of Commerce saying that RISC-V is actually a threat to US hegemony in the field, and that it's undermining export controls that are being put on chip technologies, chip designs, because it allows US and Chinese companies to collaborate on technology. So you can see that this open standard has developed in a quite contested field where there are geopolitical rivalries, economic competition, and it's quite surprising at first to say, how is it possible that this emerged? How is it possible that this even emerged at this moment? And how has this process of standardization of RISC-V been affected by these geopolitical tensions? So that's the research questions I've tried to answer in the paper I wrote on this. Here, I won't be too long in detailing the literature review in the paper, but basically I'm using as conceptual frameworks actor network theory from science and technology studies and institutionalism, and mostly the theories developed by Elinor Ostrom's on design principles for commons-based governance. And I've tried to get data from various sources, so triangulate public presentation, public reports, but also observation. I became a member of RISC-V. I participated in the summit that happened in Paris this year. I've also collected historical membership data over the past 10 years to see where the organization were headquartered, and conducted interviews with insiders from the RISC-V organization, but also members. And the first results of the research is quite obvious. So here again, I won't spend too much time on this, but based on the analysis I did, you can say that geopolitical tensions over the past 10 years in the semiconductor industry have only increased. So starting with 2016, where Huawei was put on the entity list of the Department of Commerce of the US, with the first Trump administration and tariffs, but also up to, in the end, also with the Biden administration, up to 400 Chinese companies being put on the entity list. With the COVID-19 supply shortage of semiconductors, and then with the global race over AI and the critical importance of chips, you can see that over the past 10 years, over this 10 years period, tensions have only increased. And in parallel, RISC-V has been only growing. So as you can see in this first slide on the top here, which was provided by RISC-V International, there's almost like an exponential growth of it in terms of memberships. If you remove individual members and you keep looking at organizations or even have corporate members who are the one actually paying for being a member, you can still see that the increase over the past 10 years is impressive. So it's a 10 times increase and a 5-time increase for corporate members. And you can see already from the slides here that there seems to be a turning point around 2019 where this growth has really accelerated. And that's actually not a coincidence, but because it's also the moment where RISC-V moved from the US to relocate in Switzerland and become RISC-V International. And this move to Switzerland has like a clear effect also on the representation of different regions within RISC-V. So it turned RISC-V really from like an academia-led open source project into something like an international standard. And you can see this in the representation of board seats by countries, that they really, after 2019, managed to stabilize around like a much more balanced representation of stakeholders, moving away from a mostly US-dominated project. But yet, of course, these first observations are not enough to either say RISC-V was unaffected by geopolitical tensions, or even to say that RISC-V benefited from this. So that's why I did like a more in-depth analysis, especially with interviews from people that were part of this process, to understand basically how geopolitical tensions not only affected RISC-V as an external force, but really were part of the RISC-V process. And so I'm going to show you a few highlights of these insights. A first important one is there are strong limitations to this analysis because there are really broader industrial trends that explain the success of RISC-V. Then I will tell you a little bit how actually RISC-V as an organization, not only the staff but also its members, were actually really good at very actively and consciously mobilize the political attention in various regions to build the RISC-V momentum and contribute to this growth. And then finally, I will tell you a little bit about how RISC-V had to adapt and actually very quickly build up various institutional arrangements, governance systems to be able to limit the risk of fragmentation, of geopolitical fragmentation. So first, limitations. Here again, I could be very long, so I'm trying to keep it short. Basically, I think key factors that have explained the success of RISC-V was first the technical proposal. It's quite simple and easy to build on. The people who have founded it, especially David Patterson, is one of the computer pioneers in the US, so enjoys a lot of legitimacy, credibility in the field, and also the founders, including him, but also Kristjan Zanovic, are actually people who had strong personal networks, not only in academia, but also in the industry. So when RISC-V started, it was really almost like a club of friends, but with people among like the biggest companies in the world within this club. And so that, of course, helped a lot to build up that momentum. But then they managed to get more and more actors involved because there are a few promises that were really quite effective, especially over the past 10 years, to attract more people to switch to the RISC-V architecture. And the first one is the freedom, of course, that is offered by a free ISA. And one thing that happened over that period is what I already mentioned earlier, is that ARM was bought by SoftBank. And this was very quickly seen as many people in the industry as a threat, because there's been like a tacit understanding in the industry where there's a lot of IP stacking and very complex interdependencies that the enforcement of IP would be, let's say, not too aggressive and always based on mutual interest. And what happened after ARM was bought by SoftBank in 2022, they actually sued Qualcomm, which is one of their biggest customers, which kind of reflects that the interdependency over IP can really be a threat to your core business and really become something where another actor can really have a life or death power over your business. And so obviously the promise offered by ISA was very interesting for many people in the industry. Then there was also a promise of economic value. Many startups were created that wouldn't have been able to be launched without having access to this technology. So it really lowered barriers to entry. It created mutualization opportunities. So for instance, firms like Alibaba, Google, big cloud providers, they need specialized chips, but they do not want to get into really the business of designing chips because it's hard to get electronics engineers. It's very costly. So having this like being mutualized is very convenient for them. So economic value is important. And finally, what RISC-V was really good at doing is presenting themselves as the future. So especially in the industry, there's this fear that Moore's law, which you might know, this idea that there's an exponential miniaturization of chips, that this might be ending. So there might be a problem of this continuous innovation in the field. And RISC-V here was offering the opportunity of, through customization, offer continued innovation, actually go over the limits of Moore's law. And that actually created this idea you have here, that, this presentation, this industry narrative that make it attractive, but that also creates this fear of missing out. So if you are not part of RISC-V, you might not be part of the technological future. So all of this, I think, explains a lot of the RISC-V success. But like, if we go back to our question of geopolitical tensions, I think here as well, RISC-V as an organization was very good at aligning different interests around these promises and the technical solution that RISC-V is offering. And you can really see that there was active work involved in pushing RISC-V as a standard. So it's not just the best technical solution that wins, but it wins because the foundation organized ambassador programs in various regions. It organized regional summits, roadshows to really sell these technologies to different industries, but also to governments. And you can see that this happened through narrative alignment, so adapting the message of RISC-V to the different political objectives of various regions. It happened through creating institutional bridges, for instance, creating the RISC lab between Shenzhen and Berkeley University. It happened through then public support, so different programs that supported the adoption of RISC-V. And yeah, I've obviously a longer version of this as well, of how like this happened in different countries. It's interesting to see that in the US there was early support by DARPA, especially with this idea in mind that you need to push for customization to support continuous innovation and get rid of some of the complexities. So the Aspire Lab between 2013 and 2018 funded UC Berkeley research in the field. In China, of course, like the RISC-V was quickly seen as a huge opportunity to get strategic autonomy. So RISC-V is a bit like a safety valve, a forking safety valve here. So that means that at any time you can actually get out of RISC-V, but still build on this technology in opposition to a proprietary solutions where you could have expert controls and you lose access to technology you are building on. And so there has been like a whole ecosystem mobilization around RISC-V really in China, where you had industrial policies, subsidies. You had the One Student, One Chip initiative targeting education programs, and the development of joint investment in industries, consortium, etc. And maybe to a lesser scale, but something similar happened in European countries where RISC-V summits and the discourse really were framed as part of European dreams of digital sovereignty, but also of the discourse on economic security after the COVID-19 supply shortage, because policymakers in the EU love it when you talk about cars, and since it's threatened the automobile industry, you can see that the discourse around RISC-V also really focused on applications in that sector. So you can see that basically RISC-V as an organization and its members managed to create these alliances with various different regions that led to policy measures, official support in different regions that all contributed to the growth of RISC-V and the growth of RISC-V members from these regions over the years. Now, of course, while all of this is being said, RISC-V was good at mobilizing this. Still, these geopolitical tensions in the end, these contradicting interests that RISC-V is trying to align, of course, are still a threat of fragmentation. So this alignment of divergent interests always creates the risk that at some point the network kind of fragments. And there are important economic fragmentation risks and technical risks around, like, especially because customizations allow so many different opportunities. There's a risk of technical fragmentation, but if we focus on the political risk, of course, the debates, for instance, in the US Congress in 2023 show that there's the potential that at some point, especially the US, might want to stop collaboration around RISC-V. I'm not a lawyer, but you know, like, it's hard to enforce direct restriction on open source publication. In the US, there's a jurisprudence that considers, for instance, open source software more or less at free speech. But still, you could imagine some restrictions when a technology is too sensitive, a weapon, etc., on even making it public. But here, in this case, the risk would be in what was discussed in the US, especially also under the lobbying, because of the influence of the lobbying by ARM, is that basically what would be possible is rather restrict companies from participating to RISC-V. And for instance, tell US companies you cannot participate in this because by doing this you're undermining export controls. So this risk is there. And these risks were actually very early identified by the people around RISC-V and its members. And it's almost like RISC-V, because of this risk, really used the playbook of how to build like a strong, resilient, commons-based governance and employed it. So in the article, I'm trying to use Ostrom's design principles to kind of make sense of the different actions that were taken by RISC-V. And one of them is a clear creation of boundaries between RISC-V and what it is opening and what it's not opening. While, for instance, at the start of RISC-V, its founders were talking about RISC-V as the next, something similar to Linux in operating systems. And now, if you go on the RISC-V website, what they will say is, we're only a standard. We are like USB, or we are like the Ethernet protocol. And we don't mess with commercial implementations. We strictly focus on a standard. And that delimitation was critical also in getting governments not to be too worried about this being really a tool for technological cooperation or for innovation sharing, etc., but just saying it's strictly agreeing on technical rules. Another important aspect was really the professionalization of the management of RISC-V. As I said, it really started as an informal club of friends. So interviewees were telling me like the board meetings were all not that serious, but this changed especially in 2018, where the Linux Foundation became an umbrella organization of RISC-V. It supported the hiring of Calista Redmond as the CEO, who is now working for NVIDIA, so it seems like she did a great job with RISC-V. And she really actively supported the transition of RISC-V to something much more structured. So she organized a membership reform in 2020. I could get into the details here, but this really formalized active representations also of members in the board. So to take away the board control a little bit from his founders, David Peterson and Krista Azanovic. And she formalized ratification process. So it's a clear system for defining the technical specification that gets recognized as standards. And finally, of course, there's the active pursuit of geographical diversification. So she was really I think she was really conscious about geopolitical tensions, and she actively looked for balanced representations of these different interests in the organization. So she actively looked for getting academics on board as well, getting different regions on board as well, to be able to say, this is a public international standard. It's not just an industry business. This also led to finally, like just this year, the recognition of RISC-V as a submitter for international standard organizations such as ISO. So again, really supporting this transition from kind of an open source industry project into something that has international legitimacy and can be considered as a standard. And here again, you can look at a little bit the proportions of corporate RISC-V members, again, those who pay for being a members, or the proportion of RISC-V board seats by countries to kind of observe this transition and this stabilization after 2020 of like a fair representation of some of the big interests within the board and within RISC-V. So I think I'll try to conclude quickly here, so still give room for a few questions. I think one interesting thing about RISC-V is that it shows the ambiguous effects of open technologies. So a little bit like some research has by Knut Blind, for instance, on open standards and sovereignty. It shows that it can act at the same time as a channel for knowledge transfer, so as something that kind of creates equality potentially, and at the same time be something that is better for the strongest player. And so something where not everyone is equal in the same manner. And that's why, of course, even for US companies that are leading in the field, it's interesting to be in there because you can influence technological development and trajectories. And that really explains how RISC-V was able to some extent instrumentalize, but align even contradictory, even competing players, and actually use those geopolitical tensions as something that fueled its growth. And so you can see that they managed to even take like the narratives in the US of technological race with China, but at the same time, China's strategy for strategical autonomy and for instance, EU pursuit of digital sovereignty. But of course, aligning all these different interests, there's still like a risk that this fragments at some point. And so you can see that to overcome this, RISC-V for me is really a playbook of they managed to frame their technical solution as like an obligatory passage point for a collective problem, and then really create like an active diplomacy and create representation, governance solutions to kind of create negotiation spaces between these diverging interests. And so for me, it shows that open technologies really become a space of active diplomacy, become a space where power is negotiated, etc. And for me, and that's the final comment here, I'm not exactly sure what I think about, how I feel about this, because at the same time you can say that this is an interesting case where academics, industries manage to organize themselves to maybe get away from stupid decisions by governments. At the same time, you could always say it's kind of weird that experts create these perfect systems where from different geographies they manage to settle technical solutions by themselves and also kind of escape some of the regulatory attention of policymakers. Of course, they adapt to this geographical space, but I think it shows like a shift in how power is distributed, even inside this value chain that was historically very vertical and centrally organized. So yeah, I think I'll stop here.